Hello again, IB Psychology students, and this is the third video in the series which is to help you write your psychology IA. So, just before we get on with it, I've gone too far ahead. Sorry about that. Yeah, we're getting a little bit enthusiastic there. So just before we get into it, and I'm sorry I've written this in capital letters. It looks like I'm shouting at you. I'm not shouting at you. They're just in capital letters. It's really, for my students, so they'll pay attention. Don't put your raw scores or your calculations in this section. A lot of students do this. Put them in an appendix and make sure that you don't have any of your participants' names on. Make sure you don't have your names on or your fellow researchers, and you don't have anything on that can identify your college or school. It all has to be blank. Don't put all your response sheets in there. You just have a blank copy of everything. Keep all your response sheets. I would suggest keeping them all until you get your final IA grade at the end of year 13, and even then hold on to them, because sometimes there are issues, very, very rarely, but if you've got all your data, then you'll be safe, you'll be fine. Okay. Right, as I always do, here I am plugging the two books that I co-wrote, specifically for IB Psychology. They are extremely user-friendly. They are summaries of key studies per topic for every single possible topic you could do in IB Psychology. So I do recommend them. Well, I would, wouldn't I? Right, now, the analysis section it's all about your results, your quantitative results. So, and it's really divided into two sections: your descriptive statistics, which are the easy ones. Pretty much no one ever gets into a flap about descriptive statistics, and the inferential statistics, which involve a little bit more hard work. Okay, so go straight into saying what your descriptive statistics were. I'm assuming most of you will use the mean for central tendency and standard deviation for dispersion. And I always say to my students, be very specific about why you use the mean and why you use standard deviation. If you just say, I use the mean because it gives an average of the data, that's a really vanilla response. Say something more meaningful, if you pardon the pun, about the mean. The mean takes into account all of the values in the data set. So as long as you don't have any outliers, it is the most sensitive form of central tendency, the most sensitive measure of central tendency. Standard deviation shows you the dispersion of your scores from the mean. Now, if maths is not your strong point, it's not my strong point, but do really research standard deviation, because you can say a lot about standard deviation in this section and in the evaluation that will really add value to your grade. So think about standard deviation. It gives you an idea as to how much variability there was per condition. So that tells you something about the performance of your participants. It tells you about whether these scores were all very, very different from each other. In other words, they are dispersed quite a long way from the mean, or whether everybody performed kind of around the mean. The closer you are to the mean, i.e. the lower your standard deviation, the more reliable your data is, because it's not showing huge fluctuations in variability. It means that you have got a tightly controlled design. But I would assume that a lot of you will have a high standard deviation simply because you've got small samples. The smaller the sample, the more likely it is that you will have a high standard deviation, simply because smaller groups give greater variability. Okay. Just state your results in words. You will be presenting them twice over probably after this, but still just state them in words. This is the mean for condition A, standard deviation, condition A, and the same for condition B. So do state them. Don't just say, oh, condition A is higher than condition B. Actually state the figures. You need to produce a graph of the means, and you need to make sure that you have clearly and correctly labelled the graph with a suitable title. And you give a brief explanation of what the graph shows. I will come to this in one of the slides that you're about to see. But this is what you need to do with the means. You present a bar graph. State in which appendix your mean and SD calculations are. And so when the person's reading it, the marker's reading it, they know where to find it. Right, so I would always say present them to 2 decimal points after the point, so 3.59. And keep it consistent. Don't have 3.2 or 2.8 in one and 3.59 somewhere else. Keep it consistent. The more consistency there is in your IA, the better. It makes you look more pulled together and more professional. Okay, so this is where the analysis becomes a little bit more than just reporting as well. You can suggest the mean for condition A is X, which suggests that Y. The standard deviation for condition B is Z, which indicates that W, blah, blah, blah. But you mustn't go beyond this in terms of evaluating. So if condition A is higher than condition B, it suggests that participants found condition A easier. I mean, don't be ashamed of saying the blinking obvious, yeah? Stating the obvious is fine for this section. Standard deviation for condition B is higher, which indicates that participants maybe found this particular task more challenging because their scores range. There's a wider range of scores, for example. The scores are dispersed from the mean more, but don't go into evaluating. Save that for the first part of your evaluation, where you can really look at why it is that condition B or whatever might have presented more challenge and might have produced more variability. It's a fine line between analysis and evaluation, and I think it's tricky. So you've really got to be careful how you phrase this, that you are not evaluating. I would always tell my students to present the means and the standard deviations in a clearly marked table. You're not going to get marks for it, but you certainly won't get any marks taken off if you still produce a nice clear table. It's not going to take you very long. It doesn't cost you any words, because words in tables are not counted towards the overall word count. It just looks good. It looks like a proper psychological report does. So in your bar graph, you want the means only. You don't need error bars, you don't need standard deviation graphed, you don't want a line graph or bar graph of every single score. It's really easy. It's just a bar graph of the 2 means. If you've got more than 2 bars on your graph, something's gone wrong. It is very, very straightforward. Some students often think they're being tricked and it's too easy. No, it really is just a bar graph. But you'll lose marks if you haven't clearly labelled and correctly identified the axes. So what's the y-axis? What's the x-axis? Give it a title. And I wouldn't just put condition A and condition B. I would say condition A, I don't know, could be something like no delay, if you're doing Glanzer and Kunich. Condition B, delay. So just make it so easy for the examiner to give you those marks. If the examiner is looking at your IA thinking, what does that mean again? They're not then going to be inclined to give you full marks because you've left question marks. Don't leave any question marks. What you must really do is look now at your means. Is one of the means higher than the other? If so, link it to your hypothesis. So do the descriptive statistics, the mean scores, suggest that you can accept your experimental hypothesis? It's fine to say yes here. You can say yes, well, these findings suggest that a 30-second distraction task does have an impact on the recency effect, for example. Don't say it's a significant result. You can just say that it appears to be a kind of approval or acceptance of your experimental hypothesis. Interestingly, sometimes, I think very rarely, but sometimes students get exactly the same mean scores for their experiment, in which case well, you don't really need to run any other tests to show that you can accept your null hypothesis, but you need to do it anyway, because two identical scores are telling you there's no difference between conditions, but you need to go through the inferential statistics anyway. Okay, now I'm not going to go through the inferential statistics with you. I will upload some guidance on how to carry out the inferential tests Mann-Whitney and Wilcoxon as a separate video. I don't want to go into it here because it takes rather a long time to explain, and I'm sure your teacher will help you. It may be that your teacher decides that you should use a different type of statistical test, but I always use Mann-Whitney and Wilcoxon because they are non-parametric tests which you have to use with your participants. You can't use parametric tests. They just won't work because you don't have an expected normal distribution. You don't have a large population. You won't necessarily be able to use interval data. Now, if everything I'm saying means nothing to you and you're thinking, what on earth is she talking about? Don't worry. Just focus on what your teacher tells you, and also you can access the information, the guidance I'm going to give you on Mann-Whitney and Wilcoxon in a separate video, which is linked with as part of this series. Now, basically, with an inferential test, you have to justify its use. So you start by saying, I am using the Mann-Whitney or Wilcoxon, whatever, because... So you look at the level of data. Now, this doesn't mean quantitative data or qualitative data. It means, have you used nominal, ordinal, or interval data? Again, you might be listening to this thinking, what? No idea what you're talking about. But don't worry, you will get to know what these things mean in the fullness of time. The design, have you used independent measures? Did you use repeated measures? Are you testing a difference or a relationship? Well, obviously you are testing a difference because you are not doing a correlation. Please ban that word correlation from everything that you write about on your IA, because a correlation is not an experiment. So students are always misusing the word correlation. So don't use it unless it is an actual correlation. And I can tell you there are very few of them that we look at in our psychology studies for IB. You state the direction of the hypothesis. Again, you might be thinking, what do you mean? Well, a non-directional hypothesis says there will be a difference. A directional hypothesis says participants who experience a 30-second distraction task will... You see the difference. There is one is stating a clear direction of the difference. The other is just saying there'll be a difference. Your level of significance is 0.05. You can go lower than this if you're using some software. I don't know what access to software you've got, but if you're doing it by hand the old-fashioned way, it's 0.05. Your observed value and your critical value, will come to those when we look at inferential tests. For the moment, just know that you will be stating all of these things when you write your statement of significance. Now, statement of significance here, again, I'm not going into it now. I will go into it on a separate video, but you have to state it clearly. You get marked on it. So if you don't write a statement of significance where you are either accepting or rejecting your null hypothesis and the focus is on the null hypothesis, then you won't get full marks for this section. And this is an easy section to get full marks on, much easier than some of the other sections. And a lot of students say, oh no, I failed my IA because I didn't find a significant result. I found that, the participants actually estimated lower speeds for smashed than they did for contacted, or there's just not enough here to show that there's an effect. It doesn't matter. You can have any result you like. It really does not matter, because the people marking your work know that you are not research psychologists, that you are students, that you will have small samples, that it is more than likely that you will not have a significant result. What you should do is grasp this as an opportunity to really evaluate the heck out of it in the next section. You should evaluate every single reason why you don't have a significant result. And then you also state which appendix you can find your calculations in. Finally, your last paragraph should be your conclusion. Now, your conclusion is not simply a repetition of what you have just done. It is looking back at what you found and forming an overall view as to what you did and your findings. Sorry, that's really badly explained. So, for example, after running your experiment, what can you conclude about X behaviour studied under Y conditions? So you might saying